My name is Jacob, and
Hi guys, my name is Christian.
And as you can hear, we are both from Denmark actually. So we in the Valley in October last year with our startup Crowdcurity, and we're part of the Boost VC, the accelerated one in San Mateo. But now we moved up to the city and we are kicking it, doing a lot of the security stuff in the Bitcoin space. So kind of the agenda today is just a quick introduction around Crowdcurity, what we actually do. Then we'll talk a bit around web application security within the Bitcoin space, and we'll give you an example of what we call capture the coin. We have hidden some private keys in our website and ask some security researchers basically go and take those. But first, Crowdcurity. So Crowdcurity is actually crowdsourced web security, so web application security. So we have built this platform where we connect at the moment around 1,000 security researchers from all around the world, and we connect them with businesses that want to improve their web security. And a lot of these businesses are Bitcoin businesses, of course. We also have a couple of non-Bitcoin, but most of them are actually Bitcoin businesses. And this is a lot of Bitcoin wallets, it's a lot of Bitcoin exchanges, and just Bitcoin business in general. Because of course all of these businesses are very interested around testing their security and doing it in a smart manner. And basically leveraging your crowd to test your security, that's a lot cheaper, it's a lot smarter, and you get a completely different kind of test of your web app compared to if you just had like a security consultant. So some of these businesses are, for example, Satoshi, which is a Canadian Bitcoin exchange. Here in the Valley, it's BitMe or Forum, some we've been testing with for some time. It's BitGo, it's Blockchain Info, it's Hive. So a lot of just Bitcoin businesses from all around the world, both in the US, in Europe. So in Europe, it's JustCoin in Norway, Poloniex, and so forth. So, how many of you are familiar with the concept of a bug bounty program? Okay, cool, great, nice. So that's basically what Crowdcurity is. It's bug bounty program as a service. Bug bounty program is basically that a business commits to paying out a reward or a bounty to a security tester if they can identify and report, make a proof of concept of how to basically identify a security issue and a proof of concept for how that could be exploited in a web application. And then they commit to paying out a bounty to that security tester. So that is basically what we're doing. So what's interesting there is that this way of approaching security mirrors kind of the way that attackers work. So if you're a malicious guy, you want to steal something from a website, you don't get rewarded per hour or how many reports you deliver or whatever, but you get rewarded basically when you're able to compromise the site. So if you want to kind of defend yourself against kind of that attack, you need to have the similar incentives on the defense side. And that is basically what we're simulating with doing kind of a bug bounty approach, because there also the security researchers are only earning their bounty once they're able to identify that specific issue. So the other thing is, of course, that you crowdsource it, meaning that you're exposing your business to people from all around the world. So there are like security testers in Australia that might be very specialized in one specific area, and a guy in Britain or somewhere else that knows some others, right? So you're really leveraging the knowledge of the crowd to test your web application, which again mirrors the threat, right? Because attackers are also all around the world. So you need to kind of have that leveling playing field. Okay, so how does all that tie into Bitcoin security? So the way that Crowdcurity basically do security testing at the web application layer. So we do it for a lot of Bitcoin businesses, but also for some non-Bitcoin businesses. And if you think around kind of the supply chain of end users having Bitcoins. So they both hold Bitcoins, they need to store them, they need to manage them, and they also need to access them. And just the fact of the matter is that in the foreseeable future, most end users are still going to access their Bitcoin basically through a web app or through the browser. So therefore, it kind of it means that security in the browser and the application layer is suddenly exposed a lot more than it was previously. And it kind of, Bitcoin kind of forced us to realize that how bad our security is online, and we now need to also improve really the security of the web application layer. And so this goes hand in hand with a lot of other developments in the security space within Bitcoin. Like you'll have a lot of startups doing cold storage around how to store your keys in a smart manner. You have startups doing multi-sig around how to manage and separate ownership and control of when to release your Bitcoin transactions. And then on top of that, you would have web application security. So you can see that's kind of like a traditional security stack, you can say, when dealing with Bitcoins. And we are one element in that kind of on the kind of facing the end users once they access the Bitcoin. Okay, so cool. So that was kind of just a big introduction to what we're doing, the state of the art of security, and how we kind of fit into that level. So I will hand over the word to Christian, who's going to walk through a couple of examples of some security issues that we see at websites and basically show how they can be exploited in our own app. So we made kind of a vulnerable app for our own website that is not live, but it's just locally. And trying to show some of these examples how they can be exploited, and hopefully you can learn for how to prevent those when building wallets and exchanges and so forth. Yeah,
are you guys seeing more trends of, I guess, better built web apps for Bitcoin, or is it still the same? Or
very good. In general, the Bitcoin businesses have a lot better security than any other apps online. I mean, just the fact that I think almost no wallet will launch today without offering two-factor authentication. And I don't think, I mean, I use Wells Fargo, I got no two-factor authentication there. So you definitely see just a completely different kind of security measures already in place in the wallets and exchanges. And that is definitely needed, but yeah, we still got kind of further to go. So yeah, I think that what we see also is that in general for security, the Bitcoin businesses, they just know that they need to act on this, and I would say a couple of years ahead now of the rest of the industry or any other web apps in terms of their security.
I think it's hard to say that, like, I think during like the last half year or year, has it changed? I don't know, I mean, you have 3 times as many as half a year ago or a year ago. I don't know, I can't really see that it has gotten better, but probably analysis would probably answer that.
Yeah, I think stuff like the multi-sig and just, you have a lot of different security measures coming through, and Crowdcurity, right? I think that it will become standard that all kind of business actually run a bug bounty program and basically to improve their security, and end users will demand that a wallet or an exchange or any kind of web app is doing this and communicating that they really take their security seriously and leveraging kind of the crowd to improve their security. Okay, so let's jump to some of the examples we see kind of how to exploit website, and after that we will talk a bit around how we do security at Crowdcurity. So what some of the things, because we are targeting ourselves, so what do we do to prevent all of these things not getting hacked, and then we'll go to capture the coin. Oh, by the way, when we're going to show capture the coin, if we're going to basically give you a private key on the screen, and if someone is able to kind of steal that in,
no, going to be a QR code.
QR
code.
There will be some Bitcoin that you can basically get for free today, and kind of we will do a live example and see what happens.
So I think what, as Jacob said, so a lot of it comes down to it can be, I mean, it's relatively easy to trick the user. So like the end user have no idea what they're doing. So and a hacker will essentially try to hack the weakest link. I'm going to show this title called Attacks. I'm going to show a few examples of like some simple things or some simple vulnerabilities in a web application, and or just like missing things. and how easy it could be to kind of compromise a user. So first thing is if a site, there's like these HTTP headers.
Can you increase the font size a little bit?
So is that? You can something like this. For instance, so I'll just also maybe increase it here a little bit. So if I look at the headers that our own site returns, there's one of them that's called X-frame options here. If I at the same time go on, let's see here. Well, you should mention Wells Fargo. So this is the login page to my Wells Fargo account. This is kind of very simple things that a lot of people forget. But what I notice here is that this header called X-frame options, either it could be same origin or deny, is missing here. This means that this page in the app is essentially vulnerable to something called clickjacking, or you can load the page in an iframe on a different domain than Wells Fargo. So if I want to record or steal credentials from any bank user, one approach would be to so I take this URL. There's this probably know this tool called JSFitting. Like this. Bang, bang, bang. But then we run this, so yeah. So what I did here is, well, I'm just like loading an iframe, and the source is the login page for Wells Fargo. And you see it works fine. If I did the same with our site or any other site, this header, it would just be a blank page. But what an attacker would do is say, okay, so this is possible. So maybe the domain called let's say, Wells Fargo, maybe that's not taken. So here he's going to buy that domain. He's going to trick a few users into going into that domain, and then he's going to load the actual Wells Fargo page within an iframe there, and the user won't notice that I'm on the wrong page. When I enter his credentials, the attacker can have a hidden frame, so they can record the credentials, forward them onto Wells Fargo, log the user in, and then quietly just run away with the login credentials, and the user wouldn't know what happened until they're missing money from their account. So it's a very simple thing, and it's a very simple fix, but some pages just don't have it. Let's see, leave this page. Another thing is you probably also heard about, or if you read a little about web application security, something called cross-site scripting. Essentially, lets an attacker or a hacker load any JavaScript, any malicious JavaScript that they want to load. And if he can load any JavaScript, he can do whatever the user can do, and a little bit more. And an example of this, so we have our, let's see here, yes, so I'm just going to log in here.
Our vulnerable app.
Yeah, so I'm just running here locally. See, I have a user. And the tester, so this is I'm a security tester, this is I'm logging into my profile, and he figures out that he can actually, in his, where he writes his a little description about himself, he can, well, he can write whatever he wants, add that, and he can then go and have a look at his profile. Bam. So whatever the tester or the page, whatever was put in the page has actually been interpreted as code and not just like rendered as it was. So the developer here is just like rendering out like the raw material and not actually escaping outputs. So in this case, I'm just like showing a word page, but normally attack would just happen in the background. You wouldn't even notice that your authenticated cookies or something gets stolen and shipped out to a URL. Or he makes a transaction on your behalf or copies of private keys. So this is just like for whatever guy can get to render this page, but if the same stuff get rendered in the admin section of your web application, then it's actually the admin's token or whatever admin's session that can get stolen, and then you do whatever the admin can do. So it could easily become very critical.
So it's a common attack, for example, if you're able to inject JavaScript, then you'll find out who are the admin users, you'll inject that JavaScript in some page, then you'll write just the admin and say, hey, I have a problem with my profile, can you please log in and see if you can fix it, right? They're logging in, at the same time you have the JavaScript running behind, sending his cookie, and you're logged in, right? And then you can do whatever he can do, as long as he's not logging out until you deleting the cookie and that kind of stuff.
So some of these attacks requires a little bit of social engineering, but often it's not very much. Like the same I showed in the beginning with this iPhone, you kind of have to have the victim load this URL somehow, but that can be done at least if you send off emails.
So to put it into context, for example, local Bitcoins, they had an issue at some point where someone was loading up, I think it was a passport information, and within that passport he had some JavaScript, similar kind of cross-site scripting attack, and then when he was emailing users, a local Bitcoin, say, hey, see, I'm a real user, here, just check my passport and you can verify exactly who I am, right? And when they kind of look at his passport, that JavaScript starts running. So that is definitely something that you want to look at.
Okay, next example here. Of course, just stop if there are any questions. Any web app probably have a password reset function. So let's see here. This guy's running. So I forgot my password. So let's start. I forgot my password. Oh, sorry, it wasn't this. So let's see. Christian at Crowdcurity. Send me instructions. Okay. See if I get something here. Okay. Just going to copy out this link that it gets sent. So this is how it typically happens, that the website sends you some kind of token that works for a few hours or expires at some point. And with that, it's going to be hooked up to a user, and the user can reset his password. But in some cases, developers would just, instead of this, I think, what is this, 20 character or something string, we've seen cases where the token is just 6 digits, no characters, and in this case you just have 1 million possibilities. And so if I want to hack Jacob's account, I would say, okay, I want to hack Jacob's account, I'm going to put in Jacob at Crowdcurity. So now I know that he has some kind of token sent to him. Then I just have to, go to the URL and then test any number from 1 to 1 million, maybe only from 100,000 to 1 million if it's like required to be 6 digits. And that could be done maybe in a few hours depending on how fast the website will respond. So just a simple thing, again. And another thing, if you notice here, I'm just going to go down here. Let's see if I can get this one to do something. I just want to get this. Yeah, so you see, often people have like JavaScript running on their applications, and we have this little Ola contact form down here, and it's sending requests back to the mothership once in a while, and maybe you have some Google Analytics or whatever you're running that sends data. And if so it sent us some kind of request here recently. And if I scroll down here, refer. Oops. here there's this referrer URL. So when OLAC receives this request, they also get the referrer URL. If we had just used a standard, we're using Rails up here, standard Rails implementation or authentication implementation, the referrer URL included this reset token sent to OLAC. And it's like very subtle thing, and you know, it probably will expire in 5 or 6 hours or whatever. But if there's some rogue employee at OLAC or you know any other service, or essentially you have this temporary password sitting there that you're suddenly sending out to other services. So again, kind of subtle thing that you know you think you're very secure, but then you're leaving information here and there. So as I just mentioned, right now we have a very standard setup. We're Rails set running on the root. If you run just the standard Rails application and authentication, you're vulnerable to something called cookie replay, or you're not really actually being logged out when you're hitting logout. So I'm going to show here. I'm going to log in again. Oh. No, I wasn't. Okay, so now I'm signed in. I'm going to go up here. This is kind of standard Rails session token. I'm going to copy that. And then I'm going to log out. You see I refresh the front page. I'm not logged in. Got it right in. I just copied the stuff we saw before, and I'm pasting in, overwriting this URL. Check. And try and load the root again. Bam, I'm logged in again. So the only thing I did was just copy like some letters. Essentially, it's my cookie that is lying in my browser, and Rails is saying, hey, delete that cookie, overwrite it with the one I'm sending you. But if for some reason that cookie sleeps somewhere, or a hacker gets access to that, no matter what the user do trying to log out, they will still be essentially logged in somewhere if there's a cookie lying somewhere. You might have a timeout function or something, but if it gets hold of this cookie, you can keep renewing it or refreshing. You essentially are logged in for life, or you have, until you reset the app secret or something really. But that's kind of a big deal. But it's not something most Rails developers know about. Yeah, just a sub little thing, but it can be very dangerous.
So normally these attacks will go hand in hand, right? So if you have a cross-site scripting, for example, error somewhere, then you have the cookie, right? And if the cookie doesn't expire, then you can do this attack basically forever.
Another thing here, it's kind of again subtle thing, but it kind of ties into the thing with the password reset I mentioned before. So I'm an attacker now, and I want to figure out who exists on this platform. So as you can see here, I'm going to enter in an email address. I'm pretty sure it doesn't exist. Hope I've set the configuration correctly. Okay, so now it tells me. So I wanted to have reset, password reset set to my email. It tells me it couldn't find the email. Okay, so this user doesn't exist. If I then try this email I kept working on. So it tells me now some instructions for the same. Essentially, I get two different feedbacks depending on if the user exists. So this is like the first step in hacking this guy. First, I figure out what users exist on the platform, or like get the correct email. Then I can start caring about how do I get the password somehow. It can be very difficult to actually hide which emails exist on a platform, but all of these little leaks just make it easier for some of the other attacks that might have seemed possible in the first place. And this is just one more of these. And then, we call it paranoid here because the authentication we use, there's like a mode in Rails where you can set up that only show the same feedback, whatever happens. Okay, so this was just like a few examples of like attacks, and there are of course many more. But just to give you an idea about all these little things that can happen, I'm just going to go through like what we have done for security and how we try to keep our platform as secure as possible. This AppSec, application security. Basically, we're using, I think we only have open source software on the platform. So for what we do for authentication, creating users, testing if users exist, is this very well-known gem called device. So yeah, we're running a Ruby on Rails, so it's just, let's see here. And the fact that device, which is our authentication gem, is maintained, it is open source, and so many eyes has already looked at this, we feel pretty confident that it doesn't have any backdoors and that it doesn't have too many bugs in there. And that goes with all the stuff that we do, that it's open source software that works like trusted repositories or trusted code. Yeah, of course, whenever a developer creates a feature or fixes a bug, there's always another guy that looks through the code and just do a code review with maybe get some errors in there. So it's just regular stuff. Yeah, and as I said, we're running a Ruby on Rails app, and one of the tools that one of the gems is something called Brakeman. If you're using Ruby on Rails, you might have heard of it, but just show you here how it looks from the terminal. Just a little bit. So what Brakeman is, it's a static code analyzer, and it is basically just going through all our code and see if there's something that we missed. So it looks at the source code. I did this earlier, so I have a bit nicer. It can also output to an HTML file. So this is the same, just in the browser. And it tells me that it found 2 vulnerabilities in our code with weak confidence. There's some file access here. There's the file name, and also there might be some cross-site scripting. And if I want, I can click on the link and get an explanation about, what is this stuff and how, what might have been wrong. So if you're running a Rails app, definitely recommend doing something like Brakeman. It goes, checks that you, do some checks. It cannot be sure, of course, but that you're not giving access to any files, or you're not have typical cross-site scripting mistakes. Yeah.
If there's common issues found in gems that you might use, people or say open source code that we took from someone else to develop that we implement in our product, but there might have been already security issues found in those that we're not aware of. I mean, Brakeman will automatically update their database, and then when we run our automatic scanner, it will look at all our codes, all our gems, and what version we're using, and kind of giving us alert for that, right? Because we're all humans, and we don't have knowledge around whatever security issues that are being found out there. So having kind of these automatic tools that we can set up and configure and run on a daily and weekly basis, and helps us just stay up to date on our code base.
Just one example I just noticed here is the link to checks. So this is just a function in Rails that you put in a piece of a string and say make it a link in the browser. And it's very tempting if, so we saw the tester profile I showed before, the tester can fill in his details, he can maybe also put a link to his GitHub or to his personal website. Sure, we want to make that a link, but the fact that Ruby code is actually running on that on that string that he's putting in, makes it vulnerable to cross-site scripting attacks, because then you can embed some JavaScript in your URL. So what I mentioned before is white box testing, looking at the source code. What we are also running is, on a periodic basis, we're running a tool called Tinfoil, or from a company called Tinfoil Security, I think it's called. And what it does is it basically just scans our web application, looks for the URLs we provided, and clicks on the link and see if we put in some settings in the password field, something that autocomplete password field, or typical hidden files that we forgot to remove or something like that. Just picking up stuff that you might have forgotten to remove away. I don't know if you guys have heard about OWASP, but if you haven't, it's a really good resource. Essentially, it's a Wikipedia for web application security. You have to know this page. It provides you top 10 list of typical vulnerabilities in a Rails app, or a WordPress app, or whatever you're running on. So you can like go through that checklist. If you don't know what a cross-site scripting attack is, go in there and see what it is and what the ramifications are. And also they have made this tool called Stop, again, black box testing. You download it to your laptop and you provide a URL, and it will start like the SIM as I mentioned before, scan for typical vulnerabilities. What else? Yeah, so we are running on Heroku, but every request made to Heroku runs through the service called Cloudflare. So they call themselves a web application firewall. So they filter a lot of stuff and make it easy to plug into the IPs of countries. And good protection about for DDoSing, and also really good for setting up like SSL certificates, or they can handle it for you that is done properly. Because they can easily make the wrong SSL settings there. We also do, so they can also do throttling, so just like limit the amount of requests coming into your app. But we also do that in the app. We use a VM called Rack Attack that Kickstarter thing made open source, just to limit requests to specific paths. Essentially, again, monitoring. We have our logs that we make it, do all our logs. We back up our logs. Should we get hacked, it's essential to have logs to go back and replay the history and figure out how did an attacker get in there. So back up the logs, but store them safely. New Relic, and we also use a tool called Upbeat, made for Django and Ruby on Rails apps. That is really good for error reporting, and they have an app that you can quickly check if there's something going on. So I really recommend Upbeat. So every request coming to our site is done over SSL. We don't accept anything else. There's this header called HTTP Strict Transport Security, I think it's called, that we are also providing, and which means that whenever a user visits our site, the browser will remember only access Crowdcurity or SSL. But there's this first initial request where a user might go to our site, like they might just do like this and hit enter. And it will, as you can see it here, but essentially it will just start doing a kind of an unencrypted request, and then of course at one point it will get redirected. But there's this little chance that attack at this point intercept the request before the encryption is in. So So what Chrome and Firefox, they actually have, they have this HSTS preloaded list, so you can submit your domain to Chromium developers and ask them to kind of bake your domain into the browser itself. So the browser will know that the domains on these lists should only ever be accessed over SSL, so there won't even be a point where the browser would try it. And that Firefox would then copy that list, and they have the same implementation there. So it's not really a crazy issue, but whatever you can add on top of security all the time, and it kind of feels nice to be like in the browser, burned in. And last but not least, we of course run a bug bounty program on ourselves all the time, because we can also make mistakes, and we also have we have vulnerabilities on our side as well that our testers have picked up and might not have been found before a hacker find it. So a bounty program is just essential to catch the stuff that slips through the cracks. Yeah, back to Jacob.
Cool. So just to adding to that, I think what we're trying to say is just what are some of the things that you can do, what you think of when building kind of web apps and traffic security. A lot of these tools, it's kind of Rails specific, but I'm sure that similar tools exist for whatever framework that you're using, right? Or for example, tools like tinfoil security that will just check for example, cross-site scripting attacks, and all these outside in and going on just your website are available to be used today. And then it's just very exciting digging down into security. But one thing is, of course, how secure our web app is it really doesn't matter if our personal security just sucks, right? So if you're able to just steal my laptop now and then still just log in and you have access to everything. So we just also want to mention that, of course, having good internal practices around, for example, always use screen lock for both for your laptop or for your smartphones or whatever. It should just be a requirement, basically, that once new employees are starting, that they are asked to set up screen lock on all devices, encrypt all hard drives. They are not allowed access to Gmail or anything before they have two-factor authentication. And it should just be like this checklist, and it takes a bit of time in the beginning to kind of have these procedures up, and it's easier to kind of go the other way around, but just kind of build them in and kind of make a culture around enforcing these type of procedures. Because simple stuff like having two-factor authentication on your Gmail, on your hosting provider, on all these other tools that you have are could be the weakest link and where attackers would go. So it's just and it improves the security so much.
So like don't like leave your laptop and run to the bathroom, because that might be the chance that someone in the room just like forward all these emails to my email and then you reset password. So routing up, it's not just security, not just like throw money at it or buy a tool and then you're safe, because if you just misbehave, then no tool can kind of do that. You just have to also think.
Yeah, and sometimes you can do stuff which is very easy and adds a lot of security. To give you an example, for example, our admin panel at Crowdcurity, of course, give us access to, for example, resetting user accounts and just do normal admin work for users on the platform. But also, it is exposed on the internet, right? So it is exposed via browser. But nobody should ever have access to that besides kind of 3 or 4 people within our team. So you can, for example, one of the things that we have done is just restricting that area of our application to IP addresses. So we have listed like 8 IP addresses, and only those will have access to that part of our application. And it's so simple. It takes like literally 10 minutes to code and do, and then you just solve all of that, right? Or not that it's kind of complete solution, but it really helps a lot, right? It means that you need to be there. Then, of course, it's frustrating sometimes when I'm on the Starbucks and I cannot log into admin, and that's just it, right? That's the kind of the trade-off you have to do in order to get this extra security. Yeah, so that's kind of tying, you can see some of the features we have in the physical world into the online world that is just, I mean, no attacker would be able to brute force our admin login. I even find it and know where it is. But then might be other weak links that we hope to identify and solve. Yeah, so that was a lot around how we do security, everything from kind of the app level to our personal security. And as we talked a bit in the beginning, we do kind of deliver a bug bounty program as a service to a lot of these Bitcoin exchanges, Bitcoin businesses. And we run, of course, our bug bounty program on our own site, which Richard mentioned, that we have paid out a couple of rewards. But we also kind of want to take bug bounty program to the next level and experimenting with different ways to do that. And one of the things, more like an experiment that we came up with, is called Capture the Coin. And I'll explain a bit around how it works, and then we will do a demo, and hopefully it will be a lot of fun. But first of all, I mean, Capture the Coin is just an experiment. So it's something that we are trying to basically learn from how we can use the features of Bitcoin to improve our own security. So I'll explain you how we're going to take here. Whoops. So what we have done is in some sensitive areas of our website, we have this is our production site. We have hidden some basically some Bitcoin private keys. So one example, for example, we have hidden a Bitcoin private key. We call that the Nakamoto reward, and on the public address corresponding to that key, we have deposited at the moment 1.5 Bitcoin. So for that, that private key to kind of unleash those Bitcoin are at the moment stored within our kind of admin panel, meaning that if some and we've been kind of public around it, right? That's saying this is the case, and basically asked security researchers to see if they can break in and just find that private key, steal it, and redeem the money. So why have we done that? So one of the things that is typical for bounty programs is that you have a business owner running an application, or a business running an application, and then you have security researchers. So the way it works is these security researchers, they will try to identify the issue, report it, and then they will have to wait for the accept or the acknowledgement of the business to basically pay out the bounty. But what we have defined here up front is basically saying, well, if someone is able to break into our admin panel or some of these sensitive areas straight away, I mean, you don't need accept for us. I mean, just take that small amount or whatever, take those Bitcoins straight away, and I mean, there's we don't need your accept, right? So it's kind of one way to experiment kind of with that feature. The other thing which provides us is that since we're kind of open and transparent around it, now we've written a blog post and everybody can just monitor these public addresses. So if we are compromised, or if someone is breaking in and taking those private keys, it's very difficult for us to lie about it and say, well, it didn't happen, or we'll have to somehow explain what happened and do it in an honest manner. And the third thing, which is of course extremely cool, is that we can monitor the blockchain. So we can monitor how the movements are on these addresses, and of course, build in automatic actions and proactive once we see any different kind of movements, and then tie those movements into our application by shutting it down, for example. This is actually what we've done. So there's in security you talk around this called intrusion detection system. That of course, if an intruder breaks into your web app, you want to detect that and take some actions based on that. And you can think around this as a way to build an intrusion detection system, but with Bitcoins, and then have monetary values on these addresses. So what I wanted to do now is I'm going to show you in our staging environment we have made a vulnerable private key and basically expose that. And what should happen if someone steals it is that we should just close down our app basically. So go to open. Yes. And tester. Yeah. So what you see here, what we have done in our production environment is that we have basically listed the public key in the tester section of one of our security tests on the platform, a fake test that we made just for the purpose, right? And the private key we have, in this case here, exposed in the vulnerable app. In the production, of course, it is hidden somewhere in the address section where it should not be accessible to anybody, right? So what I want to do now is basically open a bit address here. So there should. Let's just show another thing. Yes. So this is. I just want to show. This is the public address of our blockchain, and there's a lot of bitcoins on here, right? It's around $1 in Bitcoin. Do we have the group around it?
So essentially, I think we're going to show you the private key that the hacker would find, say within our admin panel, in this case, in a profile that should be private. And if they are able to get to that private key thing, and we would want to react to that via.
Yes. So I don't know if you are ready, or if there is someone who will be able to basically take that private key and
Volunteer. Well, wallets.
And it would be good if you can kind of, you need to move the Bitcoin out of your, into another address.
Oh, sorry, you just go. If you're faster, then go for it.
Oh no.
I should get a notification.
So with it, it's kind of glued together, different services, so hopefully it works. But if someone gets a chance to use Bitcoin, then
Oh, you already got it.
Is it away?
yes, I got a text at least.
You got a text. Okay, so what just happened? Yes, exactly. So basically we are monitoring the blockchain, and someone kind of swept the address and took it in, moved those Bitcoin into their own address. So we've just set up, we are monitoring that, putting in a request back to our app, basically shutting it down and putting it in the maintenance mode. So if we go to our application here, and I would reload, so it's just shut down, right? So this is pretty cool, because nobody would be, you would basically stop there as an attacker, right? Imagine, so right now we just put, $1, but imagine that it was $10,000, or $100,000, or $1 million. You could put in these keys different places on your app, and if I want to attack it, I would each time look up that, okay, how much is on there? Now I'm going to dig a bit deeper, right? But at some point, 1 million, okay, I'll take it, and I'll close down the app, right? Or you have to be very strategic around, okay, I'll go around and I'll pick all these private keys, and then I'll redeem all of them. But it becomes kind of a strategic game, and that is, or someone else doing, right? It becomes a competition. But we just know for sure that if someone, grabs those Bitcoin, we'll close our app, we'll monitor it, and
Go back on the logs and see what the hell happened.
what happened, right? And you can do it in even, so now it's done very simple. We just monitor movements, but why stop there? You could also just, look at different, so how much is being moved out, right? It could also be that if you see transactions above, I don't know, a certain amount of Bitcoin, that you just close your app, right?
Or it's just like some simple stuff that you, leaking kind of less important information, and it's more important that your app keeps on, restrict certain areas of the app or kind of go in between mode. So you can easily kind of configure this. We just made this kind of example, just like shut down the app until we figure out what happened.
So you can think of that kind of, what we're thinking around is combining really the analytics of the transactions that we see on the blockchain with the security of our app, right? If you got all that in your browser. Anyway, thank you for participating, and you got some money there. So,
are there any questions, Nathan?
Yeah.
Yes. What's the potential importance of this perspective on web app security to startup businesses?
What's the
potential importance of this to startup businesses?
Well, I think if you just started yesterday, and if you're not doing a Bitcoin business, you have to have something to protect. If you do your security first, then you never, get off the ground as a startup. What is there to protect? But as soon as you start to having, of course, with the Bitcoin, but it could also just be whatever information you have about users. You just start caring more and more. And the more data or money that you keep, of course, you have to think more about it. The users are essentially, whatever it's Bitcoin or information, they're trusting with the data. So,
but I think one of the things that we see is that being a startup now, just 3 guys and doing something with Bitcoin. If you're just having a bit of value, you need to think about security very early on in the startup's lifetime. And that is something completely new, because security used to be something for banks, right? And you have big corporate institutions with a lot of money. And therefore you also need new security solutions where you can just, in 3 clicks, get up and running. It has to be cheaper, it has to be smarter, it has to be more agile. And that is kind of all that what kind of the Bitcoin really is pushing into the kind of the security space. And that we, of course, believe that we can help solve. Right?
Good kill frac from Tariq. So if there are any more questions, then just come and join us afterwards, and then so we can people can hear some.